All right, so today we're going to talk about factoring quadratic equations when you have an A term, a B term, and a C term, specifically when you have a B term. Remember, your quadratic equations are written in the form ax squared plus bx plus c, and typically we have them equal to 0. And today you're going to learn why they're equal to 0. So if you have a quadratic equation with an A term and a B term, you can't solve it by isolating because x squared and x are not like terms. So you need another method. So the method we're going to do is called the factoring method. So go ahead and take a look at the 5x squared plus 23x minus 10 and factor that into two binomials. Now, if you forget how to factor, I'm going to do the factoring portion of this lesson today very quickly. So if you need a reminder of how to factor, perhaps you want to stop this video and check out my quick factoring review to help you remember how to factor. Okay, but if you do remember how to factor, go ahead and stop the video and factor this problem on your own. So when you factor that, you should have gotten 5x minus 2 times x plus 5. Now remember, this is an equation, and this equation is equal to 0. Now, it's important to recognize that this equation is equal to 0, because if you think about it, just a little side note, you don't need to write this part down. If you're multiplying two things, like a times b, and I say that that's equal to 0, well, then that must mean that either a is equal to 0 or b is equal to 0. One of these things has to be equal to 0. Well, if you think about your two factors, well, when you have two sets of parentheses next to each other, what you're doing is you're multiplying those. So if these two sets of parentheses have to multiply together to give me 0, that means that the value of this set of parentheses needs to be 0, or the value of the other set of parentheses needs to be 0. So what's cool about the fact that I've factored is that I've now broken this quadratic equation into two factors that are linear. And if I want this set of parentheses to be equal to 0, I just need to figure out what value of x makes 5x minus 2 0. So essentially what I have to think through is, well, what makes 5x minus 2 equal to 0? Now, if you can't do it in your head, you just write down an equation. So now this is where you should start writing again. So I'm going to set 5x minus 2 equal to 0, and I'm going to solve that equation. So I'm going to add 2 to both sides, and I'm going to get 5x is equal to 2. And then to get x alone, I'm going to divide both sides by 5, and I'm going to get that x is equal to 2/5. So if you think about that, x equals 2/5 would be a solution. If I were to put 2/5 in for x here, 5 times 2/5 is 2, minus 2 is 0. So this set of parentheses would be 0, so it wouldn't even matter what 2/5 plus 5 is, because the whole equation would still be equal to 0. That would also be true if I put 2/5 in for x up here, you will get 0. Now, because it's quadratic, there's more than one solution. So the other solution would be, well, what makes this set of parentheses equal to 0? So you set the same thing. Many of you might already know it's -5, but you just basically set that expression equal to 0, and you solve that equation for x, and you get that x is equal to -5. So the solutions to this equation are -5 and 2/5, and we often just write the solution in set notation. Let's go ahead and take a look at some more. This method only works if the entire equation is equal to 0, right? Because of that rule for 0. If you multiply two things together, the result is 0. You know one of them is going to be 0. So the first step is always to get the entire equation equal to 0. So you got to move some stuff around. So looking at this first one in the first column, to get everything equal to 0, you should add 48 to both sides. And then because you're going to end up factoring, you want to make sure that you write your terms in the ax squared plus bx plus c order. So I'm going to have here negative x squared plus 8x plus 48 is equal to 0. All right. Now, step number 2 is that you are actually going to now factor this whole thing completely. So Really quickly, I want to remind you that this also includes taking out GCFs. And if your first term, the x squared term, is negative, it's always going to be easier to factor if you pull that negative out. So we're going to go ahead and pull this negative out like it's a -1 as a GCF. You could also just put a negative sign in front of it. So you have a -1, and then you're going to be left with x squared minus 8x minus 48 equals 0. So now that GCF, because it does not have a variable attached to it, it's just going to hang out here for our factoring. And then go ahead and factor x squared minus 8x minus 48. So I already know I'm going to break x squared into x, and my signs have to be different because of -48. So I'm looking for two things that multiply to give me -48 and add to give me -8, which is going to be +4 and -12. So now that you've factored it, you set each factor equal to 0. So the GCF out here, it is a factor, but if you set -1 equal to 0, that doesn't make any sense, right? Because we're not solving for a variable here. So in this case, that GCF can just get ignored. But then I set x plus 4, that's a factor, equal to 0. And x minus 12 is a factor. You set that equal to 0. And then you solve each of your linear equations. So when I solve x plus 4, I'm going to subtract 4 from both sides. I'm going to get x is equal to -4. And then in the other one, I'm going to add 12 to both sides. And I'm going to get here that x is equal to 12. So my solution is that x is equal to -4 and 12. So you can put it in set notation, or you can just write your answer as x equals -4 and 12. Okay? Now what you're going to do is you're going to check it. And you have to make sure you check your answer into the original equation, and you have to check both, right? So I'm going to plug -4 in for x up into the top. So I'm replacing x in -x squared plus 8x equals -48 with a -4. So I have a minus sign in front of there. Remember, when you square a negative, you have to put it in parentheses. And then I'm going to do 8 times -4. And I'm going to see, does that equal -48? And so then I'm going to square my -4, and that's 16, but you have a minus sign in front of it, so that's -16. And then 8 times -4 is -32, so that's 16 minus 32. And 16 minus 32 is -48, so that one does work. And then I'm going to put 12 into the x squared as well. So let me go ahead and move my screen over because I'm kind of running out of room here. So I'm going to now put the -12 in there. So do my check over here. If you've run out of room, you can do it on another sheet of paper. So I'm going to do a negative and then 12 squared plus 8 times 12 equals -48. And then 12 squared is 144, but there is a negative sign there, so that's -144. And then 8 times 12 is 96. And if I plugged -144 plus 96 into the calculator, it would give me -48. And whenever you do a check, I think you should use a calculator just so your brain doesn't play tricks on you. So the answer to the question is -4 and 12, and our checks do work out. Let's go ahead and take a look at the problem on the right-hand side. So the problem on the right-hand side, I've gone ahead and taken this problem and put it over here. So you're working in the right-hand column now. So 15x squared minus 5x minus 6 equals -6. So first step, you got to make sure this entire thing is equal to 0. So again, if you forget how to do this, if you don't know where to start, I've put the steps off to the side to help you. So to get the whole thing equal to 0, I've got to add 6 to both sides. Just basically moving everything to one side of the equal sign. Well, what happens here is that my 6's cancel out on both sides. So what I'm left with is 15x squared minus 5x equals 0. Now this one is a great one to factor if you can remember how. When you're missing a C term and you're factoring, you just have to pull out the GCF. And so the GCF here is 5x. Remember, you got to pull out the x because they both have an x on it, and what's left is 3x minus 1. And remember, this is an equation, so the whole thing equals 0. Now your factors are 5x and 3x minus 1. To solve it, you set each factor equal to 0. So I'm going to say 5x equals 0, and I'm going to say 3x minus 1 equals 0. So now to get x alone, in the first equation, you divide everything by 5. Well, 0 divided by 5 is 0. So x equals 0 is a solution. And then here you're going to add 1 to both sides, and you get 3x equals 1. Divide both sides by 3, and you get x is equal to 1/3. So my solution is 0 and 1/3. So that would be the answer to the question. That's the solution, the value of x. So now to do your check, you're going to check in your original equation. So I'm going to check 0 first. So I'm going to do 15 times x squared, which is going to be 0 squared, minus 5 times 0 minus 6 equals -6. Now if you think about this, 0 squared is 0 times 15 is 0. -5 times 0 is 0. So what I have is 0 minus 6. And 0 minus 6 is -6. So you do get -6 equals -6 on the first one. Now the next one, for 1/3, if you're going to check 1/3, I want to move the whole thing and it's only letting me move parts of it. Okay, if I'm going to do 1/3, I'm going to do 15 times 1/3 squared minus 5 times 1/3 minus 6 equals -6. Now we're not going to panic because we have a fraction. We are good at fractions. We've been doing this all year. So 1/3 squared, remember you square the top and the bottom. So that's 1/9. So I'm going to make my 15 over 1 times 1/9 minus, I'm going to go ahead and write my 5 as 5/1 times 1/3 minus 6 equals -6. So now remember, when you multiply, you can cross cancel. So 3 goes into 9 and 15. So that's going to give me 5 and 3. So what this gives me is 5/3. And then here, when you multiply 5/1 times 1/3, that's also 5/3. So you're subtracting 5/3 from 5/3, which does give you 0. So you get 0 minus 6 equals -6. So both sides do work out. So moving right along, I would like you to stop the video and give number 1 a try on your own, your solve and your check. Give it a try. So for this one, step 1, you didn't have to move anything around because the entire equation was equal to 0. I factored it into x minus 3 times x plus 4. And then you set each of these factors equal to 0, solve those equations, and you get that your answer is 3 and -4. I put my answer in set notation, and I put them in order from least to greatest because it's set notation. It doesn't matter. I'm not going to take off if you don't do that. I'm also fine if you just leave your answer like this. And so when you do your checks, both of them should end up giving you 0 equals 0. So now for question number 2, I'm going to get you started on it. You do have to get this whole thing equal to 0. And now when you move everything, make sure when you rewrite the problem, you put everything in the correct order. It should go ax squared plus bx plus c equals 0. Always put your x squared term first, your x term second, and make the whole thing equal to 0. All right? Stop the video and give it a try. So when you did this one, if you put everything in the correct order, x squared minus 12x plus 36, it's pretty easy to factor. This factors into x minus 6 times x minus 6, or x minus 6 squared. This is an example of a problem that just has one solution because both of your factors are exactly the same. So you would have to add 6 to both sides, and you would get that the answer is 6. So bonus, you only had to do one check because there was only one solution. So I do encourage you, if you feel confident, to stop the video and try 3 and 4 on your own. I'm going to go ahead and walk you through 3 because some people just get a little bit stuck on that one. So this one only has a 6x squared equal to 8x. Again, you still have to get the whole thing equal to 0. So I'm going to subtract 8x from both sides, leaving me with 6x squared minus 8x. So you get 6x squared minus 8x equals 0. So you have to remember, all you got to do is pull out a GCF for this one. So for this one, you're going to pull out a GCF of 2x because they have a 2 in common and an x. And then you divide the 6x squared minus 8x by 2x, and you are left with 3x minus 4. And that whole thing is equal to 0. So now your two factors are the 2x, so you set 2x equal to 0, and then you set 3x minus 4 equal to 0, and you solve for x. Here, you divide both sides by 2, and you'll get that x is equal to 0, which is one of your solutions. And then here, you're going to add 4 to both sides, and you get 3x equals 4. Divide everything by 3, and you get that x is equal to 4/3. So my answer is 0 and 4/3. You could also say that's 1 1/3. Okay? Now to check, checking 0 is super simple. I'm going to do 6 times 0 squared equals 8 times 0. And then you follow the order of operations on both sides. So 0 squared is 0, 6 times 0 is 0, and 8 times 0 is 0. So you do get that both sides are equal to 0. Now checking 4/3, you're replacing the x with 4/3, so I'm going to have 6 times 4/3 squared equals 8 times 4/3. So now when you square 4/3, you just square the 4 and the 3. So 4 times 4 is 16. 3 times 3 is 9. And then 6, I'm going to write a 6 over 1. And then remember, I can cross cancel, right? I can reduce the 6 and the 9 to become 2 and 3, which then now I multiply straight across. 2 times 16 is 32, and 1 times 3 is 3. So this side of the equation is equal to 32 over 3. When I do this, I'm going to do 8 over 1 times 4 over 3. You can't do any cross canceling, but if you multiply straight across, 8 times 4 is 32, and 1 times 3 is 3. So since both sides of the equation are equal, that's how you know that 4/3 is a solution. All right? Now jumping on to number 4. Now number 4, you might be like, wait a second, this isn't a quadratic equation, and you're right. This one right here is a cubic equation, but that's okay. We can still solve it the same way. So cubic equations, you just put them in order from the highest exponent down to the lowest exponent. You still have to get the whole thing equal to 0. So I'm going to add the 3x squared to both sides, and that 3x squared should live in the middle, right? So I'm going to start this with 6x to the third. Then I'm going to do plus 3x squared in the middle minus 45x. And then the whole thing is now equal to 0. So since we have an x cubed, an x squared, and an x, they all have an x in common, which is why I can solve this problem by factoring. So what I'm going to do is I'm going to pull out my GCF. My GCF is 3x. So when I pull out a 3x, I'm going to be left with 2x squared plus x minus 15. And that whole thing will equal 0. Now I bring down the 3x. Don't forget about the 3x as your GCF. And then I'm going to factor the 2x squared plus x minus 15. I'm going to factor that. I'm going to break the 2x squared into 2x times x. I know my signs have to be different. And I'm thinking of factors of 15, which come to 5 and 3. I'm going to quickly check my inners and outers. So I'm going to get negative 5x in the middle and 6x. So here I'll point to what I'm doing. 5x here is negative 5x, and then 2x times 3 gives me 6x. And negative 5x plus 6x does give me that 1x in the middle. Okay? Now, don't forget, we're actually trying to solve the equation. So we have to now set every factor equal to 0. And in this case, because it's cubic, I actually have 3 factors. So I'm going to set 3x equal to 0 and solve that equation. I'm going to set 2x minus 5 equal to 0 and solve that equation. And I'm going to set x plus 3 equal to 0 and solve that equation. So the first one, when you divide both sides by 3, you should get that x is equal to 0. For this next one, you're going to add 5 to both sides and get 2x equals 5. And then divide everything by 2, and you get that x is equal to 5 over 2. And in the last one, you subtract 3 from both sides, and you get that x is equal to negative 3. So your solutions, you have 3 of them. And I'm running out of room, so I'm going to just put it here. You've got 3 of them, so it's going to be negative 3, 0, and 5 over 2. And I'm just putting them in order from least to greatest. It's fine. It doesn't matter what order you put them in. All right, so this is equation, because it's cubic, has 3 possible solutions. So unfortunately, I am going to need to check all 3. I give you permission to pick 2 of them and check 2 of them and see if they work out. And they should. I will put my work for all 3 checks on a blank page on the next page. So stop the video, do your checks, and then you can chime back in and see if you've got your checks correct. Go ahead and take a look at your checks. And if you checked the fraction and did it correctly, I commend you. That problem was very difficult. So if you think you got one of your checks wrong, stop the video and just kind of look at it closer. Let's go ahead and move on to number 5. So for number 5, I want you to stop the video and just factor that one and see what you get your solutions. Don't check this one though. Once you're done, chime back in to see if you got it correctly, and then we'll talk about it some more. So hopefully when you factored, you noticed that this problem was a difference of 2 squares. So it factors into 7x plus 3 times 7x minus 3. And so when you solve each of those equations, for the addition one, you get negative 3/7 as a solution. And then for the other one, you get positive 3/7 as a solution. So you could write your answer as plus or minus 3/7 because they're opposites of each other. If you separated them as negative 3/7 and 3/7, it's still correct, but I just wanted to let you know this is the shorthand way of doing it. So then I didn't want you to check this one because I also wanted to remind you this is a problem. It doesn't have a b term, it doesn't have an x term. So you could have solved this equation by isolating the variable. So rather than do a check, we're just going to solve this equation by isolating the variable. And I just want to show you how we still get the same answer. So I'm going to rewrite the problem. And now if I'm going to isolate the variable, you're going to add 9 to both sides. The reason we can do this is because we just have an x squared. So now I have 49x squared is equal to 9. And then I'm going to divide everything by 49. And then I have a fraction. I have that x squared is equal to 9 over 49. And so now to get x alone, you find the square root of the whole thing. Because 9 over 49 is a fraction, I'm going to find the square root of the top and the bottom. And then remember, when you find the square root of both sides of an equation, you have to remember that a positive squared and a negative squared all result in a positive. So that's where my plus or minus comes in. The square root of negative 9/49 is plus or minus 3/7 because the square root of 9 is 3 and the square root of 49 is 7. So you still get the same answer by isolating the variable. Now, last problem in today's video. Stop the video, try number 6 completely on your own, and then let's just check in with each other and see if we agree on the answer. And I think if we do, we can skip the check. So if you are confused a little bit about getting this whole thing equal to 0, you do have to subtract 43x. And because that's a like term with 15x, you're subtracting it from 15. And you do have to add 6. And because that's a like term with your constant of 10, you're adding it to 10. Now, when you go to factor this, don't forget you have a GCF. So now if you have gotten further, stay tuned. If you haven't, stop the video and keep working. So your final answer for this one, you should have gotten 1 4/3 or 1 1/3. I want to point out that you did have a GCF here of 4, but because that GCF doesn't have a variable on it, you can ignore it, right? It is a factor, but that's clearly not your factor that's equal to 0 because it's equal to 4, right? That's already a number. So variables, GCFs that have variables, you can't ignore those, but GCFs that don't have variables, you can ignore them when you're solving, okay? These two factors ended up giving me 4/3 and 1. Good luck with your practice. Let me know if you've got any questions.